So have you ever really stopped to think about what's happening inside your computer? We're going to go on a little journey today, deep inside the machine. We're going to pull back the curtain on what happens in that tiny fraction of a second, that moment that turns a simple key press into something you can actually see and use. So let's do it. Let's follow that one little key press and see the incredible dance that makes it all happen.
It feels like magic, right? You tap a key and boom, the letter just appears. But it's not magic at all. It's this incredibly fast, perfectly organized process. That one little tap kicks off a whole journey for a piece of data. And right now, we're going to follow it every single step of the way.
And here's our game plan. First, we'll cover the absolute basics. Then, we'll look at how we actually talk to the computer. After that, we dive into the digital brain to see how it thinks. And finally, we'll see how it shows us the results. Simple as that.
Okay, before we can really start our journey, we need to get the lay of the land. The world our data is about to travel through is really made of two very different but totally essential parts.
You've got your hardware on one side, that's all the physical stuff, the things you can actually pick up and touch. And on the other side, you have software, all the invisible instructions. Now here's the key, they are a team. One is useless without the other. You could think of software as the translator that turns what we want into a language the physical hardware can actually understand and act on.
And here's the thing, it doesn't matter what you're doing, playing a game, sending an email, whatever. Every single thing your computer does boils down to this fundamental four-step loop. It takes information in, it thinks about it, it saves it, and then it shows you the result. That's it. So let's start at the beginning, getting the information in. So how do we kick things off? How do we get our thoughts, our commands into this machine in the first place? Well, this is where our little piece of data officially begins its adventure.
We do it with what are called input devices. These are basically the computer's senses, its eyes and its ears. They are the gateways that take our instructions from our world, the physical world, and translate them into a digital language the computer can work with. This is what kicks the whole process off.
Now, the keyboard and mouse are the ones we all think of, but they're everywhere. A microphone turns your voice into data. A scanner turns a drawing into a digital file. Even the barcode reader at the grocery store is an input device, zapping that product code right into the register. They all do the same basic job. Get information into the machine.
Okay, our instruction made it inside. Now we're heading to the main event, the heart of the whole operation. This is where the magic happens, where your simple key press actually gets understood and acted upon.
And the center of it all is the Central Processing Unit, or CPU. It's not an exaggeration to call it the brain of the computer. I mean, this quote nails it. It's the mission control that reads, understands, and carries out every single command for the entire system.
And if you look inside this brain, it's pretty fascinating. You've got the control unit. Think of it like a traffic cop, telling all the data where to go and when. Then there's the arithmetic logic unit, the ALU. This is the master calculator that does all the math at incredible speeds. And the CPU's own personal sticky notes are called registers. They're these tiny, super fast spots that hold the exact piece of data the calculator is working on at that very instant.
Now, to do all this work, the CPU needs a desk, a workspace. And that's primary memory, which we all know is RAM. You can literally think of it as a workbench. It's lightning fast and holds everything you're currently working on. But, and this is a big but, it's volatile. That means if the power goes out, poof, everything on the workbench is gone for good.
For anything you want to keep permanently, you need secondary memory, your storage. This is the computer's long-term memory, its digital filing cabinet. This could be an older, spinning hard drive or one of the newer, crazy-fast solid-state drives. The main thing is it's non-volatile. Your files are safe and sound, even with the power off. So let's put it together. When you want to open a file, the computer runs over to the filing cabinet, your storage, grabs a copy of that file, and slaps it down on the workbench, your RAM. This lets the CPU work on it at top speed. It's why having a fast storage drive and lots of RAM makes your computer feel so snappy.
And the amount of space we're talking about, both in the filing cabinet and on the workbench, gets huge fast. A kilobyte is about 1,000 bytes. A gigabyte? That's over 1 billion. And a terabyte, which is pretty common now, is over 1 trillion bytes of information. It's just a mind-boggling scale.
All right, our key press has been received, it's been processed by the brain, and it's been stored. The computer has officially done its thinking. But so what? How do we actually see what it did? This brings us to the final step of the journey. And that is the job of output devices. I mean, all that processing is totally useless if we can't see or hear the result, right? Output devices are what take all those digital signals from the CPU and translate them back into something we humans can understand. Light on a screen, ink on a page, or sound in the air.
Your monitor is the big one, of course. It gives you a soft copy of the information. If you want a hard copy, well, that's what a printer's for. And of course, speakers give you audio. These devices are the final destination, the end of the line for our data's journey, making all that internal work actually useful to us.
And there it is, the whole trip from start to finish. You press a key on your keyboard, that's input. The CPU figures out what that key press means, that's process. It uses RAM and your hard drive, that's store. And finally, the letter pops up on your screen, that's output. Every single thing your computer does follows that exact same loop.
You know, it's pretty amazing when you think about it. This basic process has stayed the same since computers were the size of a room. All that's changed is that everything has gotten unbelievably smaller and faster. So it really makes you wonder, right? As these parts keep shrinking and accelerating, what's the next leap? What new ways of putting information in, processing it, and getting it back out are just around the corner?